We have started recording. Yep. Where is 7? Okay. So let me just take this question. So this is the question 7. Okay, so this is 20 in the power. In case it is not visible properly, this is 20. Okay. So they're asking what is the trace of. So if I say that A is this matrix 2 1 0 0 2 0 0 0 3, then they are asking for what? They are asking for the trace of A power 20. So we know
Wait,
the trace of.
hello.
Huh?
Hello. This is
Yeah.
assignment number 8, I think so. Or
Yeah, this is
questions.
8, assignment 8.
You were discussing?
Huh?
Okay. Assignment 8.
We were doing 8, no?
Yeah, I did.
Yep, we were
Okay,
doing 8,
no
yep.
doubt. Okay, 7, 8. Yeah,
So
okay.
we are
7 and
looking
8
at the.
also. I
So
did.
we want to look at the trace of A power 20, right? So we know the trace of A power 20 will be same as the sum of eigenvalues of A power 20, right? So what are the eigenvalues of A power 20? So we also know that the eigenvalues of A power 20 will be same as, so I'll just write sigma A power 20. This is the set of all eigenvalues. That is nothing but lambda 1 power 20, right? Lambda 2 power 20, or I mean I'll just write it down since we all know the results. It is nothing but 2 power 20, 2 power 20 and 3 power 20. Because why? Because 2, 2, 3 are the eigenvalues of A, right? So by this I mean the set of eigenvalues. Okay. So what will be the trace? 2 power 20 plus 2 power 20 plus 3 power 20. That is twice of 2 power 20 plus 3 power 20. Right? This one is the answer. Right? This is straightforward. Shall we go to the next question? Question number 8. Any doubts or anything? Hello.
We can solve it.
Oh,
We
I
can
mean,
solve, no doubt. Question number 9.
no doubt.
Yeah,
Okay.
Rohit, by taking
Yeah.
some matrix, particular matrix, and that can be done. But I want to see so how this can be proved.
Take
Just
general ABCD.
Okay,
and
Actually, it is
fix.
2
You
by
will
2,
get
no?
18 minus
So
18
it will be easy.
okay, okay.
Question number 9.
Still, I mean, just for the sake of completeness, I'll just solve this quickly. So the idea is that what do we want? We want so one method is you can take this way, right? This is one method. Another method is since they have only asked for determinants and traces, right? See, like what will be the eigen? So let lambda 1 and lambda 2 be eigenvalues of A, okay, right? Then what will be the eigenvalues of I plus A or A plus I? That will be 1 plus lambda 1 and 1 plus lambda 2, right? So the determinant of A plus I will be 1 plus lambda 1 times 1 plus lambda 2. This is okay, which is nothing but 1 plus lambda 1 plus lambda 2 plus lambda 1 lambda 2, right? And this 1 plus determinant of A will be 1 plus lambda 1 lambda 2, right? What does this mean? This just means that summation, I mean lambda 1 plus lambda 2 is 0, right? This is what it means, right? So that means the trace is 0, right? And what else can we conclude? Determinant need not be 0. Okay. Determinant need not be 0. A need not be 0 matrix. All those you can find examples. These are all examples. Yep, so that's pretty much it. Let's go ahead. What about 9? 9 is also like we have done this many times, no?
9, I have a doubt. Yeah, no.
Okay.
Can we do this by using this 9?
Using what? Using? Hello?
Using what is known as transformation.
Transformation, yeah.
Missions.
Huh? Transformation, right? See, first of all, what is AB?
Yeah.
AB will be from पहले B उसके बाद A, यानी कि N से M, so it will be from N dimensional space to M dimensional space to N dimensional space, right? And which one is bigger? N is bigger. So you're going from a big space to a small space and back to a big space. So you can never cover the you can never cover the big space. That means it is not onto. That means it is not invertible, right? Right. So AB is never invertible. Never invertible. So not invertible means what? It is singular, right? AB is always singular. Okay. Now if you look at BA is from M dimension, which is a smaller one, to bigger one, N dimension, to again back to a smaller one, right? So this we saw that we have produced multiple examples for which this is a bijective map, right? In fact, you can also make it the identity map. I mean, you can easily construct an example. So this can be invertible, right? Can be invertible. Okay, not that it will be invertible. It can be invertible. It can be non-invertible also, right? Can be non-invertible also. Just map everything to say, for example, in A itself, map everything to 0, right? Then it will be non-invertible. Okay, so both are possible. So nothing can be concluded about BA. Right? This is definitely not. This is okay.
Yeah, got it.
This examples we have done.
That means product of the matrix or the composition of matrices.
Right. Yeah, this we discussed, no, last time. Not last time. I think the few days back. Yeah.
This time also. That time the transformation was there. So we are thinking the T of last time. No, not product. Okay. Anything.
What about the next one? 5 by 5 matrix. This is also straightforward, no?
इसका आंसर ओनली ए ट्रू होगा ना
A square, हाँ, less than equal to 3 होगा, हाँ. Yeah, correct. Wait, 1 minute. Yeah, correct. And determinant of A square will also be 0, right? A and D, right?
yes वो तो देखा है okay
ये straightforward है ना?
कभी-कभी MSQ के जो क्वेश्चन आते हैं ना, so in the MSQ, so what should we do? Means should we tick option C also?
No. Option C is not correct, no.
Okay.
See, what I'm saying is that they are saying solution span of this at least 2. It can be 3 also.
Okay. Yes.
3, then. Okay, 1 minute, guys. 1 minute. ഹലോ ഞാൻ കുറച്ചുകൊണ്ട് വിളിക്കാം കേട്ടോ. ശരി ഓക്കെ. Yeah, so the solution, they're saying it's at least 2, right? So it can be 3 also. In this case, if the solution span is 3, then the rank will be 2, right? Wait, 1 minute. No. 1 minute. 1 minute,
Yeah.
guys. 1 minute. So basically, they're saying that the nullity is bigger than equal to 2. That means the rank is less than equal to 3, right? Rank of A square will be
0, 1, 2, 3.
less than equal to 3, right? Fine. Yeah, it will be less than equal to 3. This is not true
How you are
because
getting rank of A and rank of A square? No, no.
come
Hello,
again.
hello, hello, hello. From
Yeah.
where you are getting rank of A square less than equal to the rank of
So rank of A square is less than equal to minimum of rank of A comma rank of A, right? Getting the point?
rank
Rank
of A
of
comma
AB
rank of A.
is less than equal to minimum
Okay.
of rank of A comma rank of B, right? This we know,
Okay.
right?
Okay.
Okay.
That,
Also, I just want to recall one more thing. There is another inequality which is rank A plus rank B minus n
it.
less than equal to rank AB. Right? This is correct, isn't it? Let me know if I'm making any mistakes. Rank A comma rank B. Is this okay?
No. That,
Yep.
Yes.
So from using this, I have concluded this. Okay. Now, so rank of A square can be is bigger than equal to rank A, which is okay. Rank A plus rank A, right? Minus 5. So this is twice rank A minus 5. Uh, so if rank A and rank A square are the same, then what would we have? Then we would have that 2r square 2. Okay, so that would be my okay. Uh, R A rank A less than equal to 5. That doesn't make okay, fine, no problem. This is not creating any trouble. Yep. So we have this. We have that rank is less than equal to 3. In fact, I mean, if you choose the null space to be, if you choose the null space to be 3, then the rank will be 2, right? In that case, the rank of A square will be less than equal to 2. In that case, this will not hold, right? Similarly, this will also not hold. Determinant A square will be 0 because because the rank of A square is strictly less than 5, right? This implies that the determinant of A is 0. Okay. Full rank nahi hai. If it is not full rank, then it is singular. Okay. This is clear. This is okay.
Okay.
Nice. Let's move ahead. What about 11? Any doubt? Any questions? Any interesting points? Hello?
yes.
Yes.
Yeah, discuss. 11 discuss.
Okay. All right. So, okay, the condition given is a power 8 is equal to I 3 by 3, right? Okay, nice. And A is a 3 by 3 matrix, okay? Okay. Minimal polynomial can only be of degree 2 degree. Achha. Okay, let's look at some okay. See, this is a very I mean, we can construct several exa examples, right? So, first of all, A can be I, right? Right. A can be I. So, what is the minimal polynomial of I? It will be x minus 1 whole cube, right? Which is of degree 3. So the first option is wrong. Okay. Now take some other A. Take A to be do I mean, what I'm thinking now, I'm thinking of taking an A which satisfies this property that A square is I, right? Right. In this case, what do we have? In this case,
भाई तुम yeah, hello, 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 hello.
हाँ
You
बताइए.
told that you're going A to I. Hello.
हाँ हाँ
You
हेलो हाँ
one whole cube. Basically, yeah, hello,
हाँ बताइए.
hello.
हाँ हाँ
What I am telling to you, you
हाँ
tell that you will take A equal to identity matrix, correct?
हाँ हाँ हाँ.
Then the characteristic polynomial will be na A minus 1 whole cube.
Yes,
Oh, so
but
yep. Right. Thanks. You're right. Yeah, that's true.
Okay.
In fact, if you take a equal to I, the characteristic polynomial will be, we know, uh, x minus 1 whole cube. What will be the minimal polynomial? X minus 1, right? Which has degree 1. That means both option A and B are
No,
false. Huh?
no. It is not like that. No, there will some see. The minimal polynomial can be x minus 1 whole square or x minus 1 or x minus 1 whole
No,
cube.
no, no, no,
There
no,
is some
no.
condition
For
to this.
No, no.
one
For
minute,
I,
for I,
Hmm?
for I.
What is
Okay,
what is the procedure to find?
I'll tell you. 1 minute. My claim is that, okay, we know this thing, right? We know that the minimal polynomial divides the characteristic polynomial, divides any annihilating polynomial. This is okay.
What is the meaning of annihilating polynomial? That means if any thing is satisfied, even the degree is what, no matter at all. Let us
Yeah, correct,
suppose
correct.
Hello.
आप और एक बार बताइए, पूरा आवाज कट गया.
Given
एनिहिलेटिंग पॉलिनोमियल मतलब यहाँ पे ए पुट करने से 0 हो जाएगा.
Zero.
Okay.
Huh?
Did anyone hear properly or
not from magician wise.
okay.
Yes, some.
No, I am telling that the annihilating polynomial of a to the power 8 equal to identity will be lambda to the power 8 minus 1 or x to the power 8 minus 1, if I am not wrong.
Uh, see, lambda to the power 8 minus 1 will be an annihilating polynomial. This is okay?
Okay.
And
Vishan, the degree of that characteristic polynomial and
Yeah.
that order of that matrix is same.
what I'm
Okay.
yeah, what my claim is here is that
No,
x minus 1 is an annihilating polynomial, right? For a equal to I. This is okay?
No,
It's not
I
okay.
did not get.
A equal to I, that implies a minus I equal to 0. That implies x minus
Okay.
1 is an annihilating polynomial. Now is it okay?
No, okay. No, I thought about a to the power 8 equal to identity. Yeah. Okay. Then it's
Yep.
okay.
Now what we have that ma of x divides any annihilating polynomial of x, right? That is x minus 1, right? What does that mean? That means max is, this is okay?
Yeah.
That means minimal polynomial has degree 1, right?
Yeah.
That discards the first two options. Is this okay? Hello?
Okay.
Yep.
Yes.
Yeah. Okay.
Yep. Okay, fine. What about a? Yeah, I mean, this is definitely not true because you take this thing, you take this matrix. 8 चाहिए ना, तो that will be pi by 4 ले लेता हूँ. Cos pi by 4 minus sin pi by 4, sin pi by 4, cos pi by 4. This matrix, observe that this thing to the power 8 will be I, right? And but this is not identity or minus identity, so C is also false. Is this okay?
Rohit bhai, we can also take minus one diagonally minus one one one.
Okay.
Other Rajya.
Yeah, minus 1,
No,
1.
diagonally.
Oh, diagonally. Okay. Sorry.
Yes.
Minus 1, 1, 1. Yep.
Yes.
Yep. This also perfect. In fact, any a which satisfies a square equal to I, you can take that, right? Because if a
Yeah,
square is
uska.
I, then yeah,
Yeah. Yes.
right. Okay. So Okay, so I mean, I'll give several arguments for. I mean, right now I can think of an argument for D. Uh, okay, just look at question, option D. It says there are uncountably many A satisfying the above. Okay, let's see. See, when you take this R3, no, this is we are dealing with three-dimensional spaces, M3, right? We have M3, so we can look at R3. Now, take any line. Let me just change the color so that take any line, right? Now rotate the space about this line. Okay, by angle. So rotate about line by angle pi by 4. Right. Then observe that if you keep no, this doesn't work. Rotation शायद. Yeah, this doesn't work. Do one thing. Yeah.
Hello,
One
Ross.
thing is, yeah, go ahead.
Please browse clearly. I didn't get it.
Okay, yeah, I mean, anyway, it was not important. Yeah, it doesn't work. I was thinking about it, but it doesn't work.
Okay, okay.
Let's do another this thing. Okay, another visual thing. So actually, I was trying to rotate by an arbitrary line. Now that my this was my plan of action. Okay, that
But that
if
from
you
that you will get countably
uncount
infinite, right?
uncountably many, because
Yeah.
you can choose uncountably many lines of rotation, right? But the thing is that if you take an arbitrary line, the rotation will not satisfy a power 8 equal to 1, right? So what I'm doing now I am changing my plan of action. Instead of line and rotation, no, I'll
Hello,
yeah,
Rohit.
go ahead.
You took one example, like rotation matrix.
Yep, this one.
Yeah. See, in place of theta pi by 4 is there, na? Take 4 and pi by 4 and
No, but the 1
8
minute.
and pi by 4.
Yeah, that is okay. What I'm saying, no, that even if you do that, the values of cos and sine will be finite, no? Are you getting my point? See, like 4n plus pi by 2 or whatever, 4n plus pi by 4, this has many values, countably many values. But the moment you take cos, this has only one value, right?
Yes, yes.
I mean only one value, right? So that is not giving us many matrices. That is only giving us the theta, right? Ultimately, the matrix we are getting will be the same. I mean,
Okay.
I'm yeah. Now I'm thinking of another this thing. No, that is so. First we tried rotation about axis. It doesn't work, right? Now I'm thinking take an arbitrary plane, right? So take an arbitrary plane, right, and reflect about the plane. So whenever you reflect about the plane, so then it will satisfy a square equal to I, right? Because you reflect two times, it will come back to identity, right? Now this arbitrary plane can be chosen in uncountably many ways, right? Right? This is okay. The arbitrary plane can be chosen in uncountably many ways. Is this okay? So suppose you look at the xy plane, right? Suppose then what would be the matrix like? The matrix would be uh, how would the matrix be? X will go to so 0, 0, 0. Right? Okay, this is one this is this is reflection about xy plane. So there can be several planes, right? So you can take plane like this, like ax plus by plus cz equal to 0, right? So you can choose several such planes, and what will be so choosing such planes is equivalent to choosing the normal vectors of the plane, normal vectors of the plane to be a comma b comma c, right? Or I think I should write it this way, a b c. So that can be chosen uncountably many ways. That means the plane can be chosen in uncountably many ways. That means the reflection can be done in uncountably many ways. Is this okay? What would be okay? So suppose I am choosing this vector and I want to reflect about this plane. Then how will what will be the matrix? How will the matrix look like? Observe that it will be suppose let me think about it. ABC go. See, ABC, where should it go? It should go to negative minus a minus 1 minute. Yeah, minus a minus b minus c, right? 1 minute. हाँ ठीक है, minus a minus b minus c, right? No, sorry.
ए बी माइनस क्या है?
Sorry guys, sorry. This requires some additional computation. So look at a plane, look at the perpendicular. Okay, I'll just draw this. Suppose this is the plane. This is an arbitrary plane. Suppose this is the origin, right? You have some vector. Say this is the vector we want to this thing. What do we want? So and this is the normal vector, right? So the normal vector. So this is nothing but ABC, right? So how? So what do we want? We want reflection about it. That is, we want this, right? This is the reflection that we want. How would you obtain that? Uh, you take you take the component here, right? So that would be what? How would you do that? Mm, 1 minute. This can be written as let me call this a vector. Now you look at, so since so what will this vector be? इसका direction क्या होगा?
A cos theta.
Come again?
भाई
हाँ बताइए.
I'm not understanding what you want to explain. तो ऊपर से एक बार explain करोगे क्या?
हाँ.
Getting confused.
Okay. एक्चुअली क्या है ना कि मतलब देखिए आपको ये तो क्लियर है ना कि अगर एक आप आर्बिट्री
इंग्लिश
प्लेन ले लीजिए.
इंग्लिश में समझ जाएंगे.
Okay, fine. So this is clear, right? That if you take an arbitrary plane and reflect about the plane, then see, what does this mean? What does reflect about the plane mean? That this means that you are doing a transformation, right? This is a transformation, right?
Okay.
And that transformation will satisfy a square equal. So what is A? A is the matrix corresponding to that transformation. So that means a square will be equal to I, right? Is this clear? Till here.
Okay.
Till here is it clear? Clear, no?
Yeah.
Okay. Now we can choose this arbitrary plane, right? In uncountably many ways.
If you are going to take the transformation, if you are going to take the transformation along any plane, it will give you identity matrix. That you're telling.
Twice.
Identity. How will you give the identity matrix?
Okay. See, I mean, what are you doing? Okay. For simplicity, what I'll do, no? Take R2. Take R2, right? And you take a line. Y equal to 2x. Now you reflect about this line. Doesn't it give a square equal to I?
Okay.
So you reflect once, it will go here. Reflect once again, it will come back, right?
Yeah.
So same idea I'm doing in R3 with planes, right? I'm trying to figure out the this thing. What is that called? The matrix. Yeah. So what were we doing? We were looking at the. Uh, so I mean, Zishan Bhaiya, you can help me with this, no? That actually I'm looking for what will be this, this vector.
What will be
Actually, I'm looking for
some projection level?
projection of x
No,
on
no.
this plane.
X. Okay. The projection will be dot
भाई आपका आवाज कट रहा है.
vector vector x
हाँ हाँ.
dot. You want magnitude, no?
No, direction. Direction and magnitude. I want both.
Direction. Yes. A plus this same.
आवाज कट रहा है भाई आपका.
The projection vector. Correct. So if it is hello,
Yeah, go ahead.
what I am telling you, the projection of vector A on vector B will be vector A.
हाँ.
B cap is vector B. This is
Jishan, your voice is not
if you
clear.
want to vector, then you have to multiply B cap.
Hello?
Yep.
Rohit, Jishan
Yeah.
voice is clear to you?
No, no, not at all. Nothing I could understand.
Yeah, me
No,
too.
I got really clear. No,
Yeah. The voice is भैया वॉइस एकदम डिस्कनेक्ट हो रहा है. अभी कुछ मुझे सुनाई नहीं दे रहा है. हेलो.
yeah, audible.
सिर्फ ऑडिबल सुनाई दिया. ऐसा कुछ बोले और कुछ सुनाई नहीं दिया. Since we are not
Move
able
ahead,
to
move
like,
ahead.
okay. Yeah, so since we are not able to find out we are not able to characterize. So this intuitive idea is clear, the geometry is clear, but we're not able to come out with a matrix. So we will use another method. Okay, let's see. What I'll do, no, uh, I'll take. Okay, so this who gave me this matrix? Kailash Bhai, right? Kailash Bhai gave me this matrix, no? No, not this one. Where is that other matrix? This one. Yeah, fine.
Yes.
Okay, so yeah, so basically they are the same. Let's see. I'll try to do something with that. So you have 1 0 0 0 1 0 0 1 minus 1, right? So things like this. Now what my plan is now? I want a non-identity. Can someone give me a non-identity, right, invertible matrix. Non-identity, non-scalar. It shouldn't be scalar, right? It shouldn't be. It should be non-diagonal. Non-diagonal. It should not be invertible matrix. Can someone give me?
Yeah,
Yeah.
Or
Group.
or 1 minute. Let's see. Yeah. Uh, yeah. Can someone give?
No, you can take one equal minus one. The third
Come again.
element.
Come again.
By minus one.
1 1 minus 1. Okay. Hello.
By zero.
0.
0 minus 1.
Okay. I'll just figure it out. I'll figure it out. Wait 1 minute. What actually my plan is uh, suppose you have 1. Okay, just take 1 1. Okay, and you take uh, alpha alpha. See, right now what will be the inverse of this matrix? We will require uh, 1. Okay, what will be the inverse of this matrix? Can someone tell me?
That will be the same.
Yep, go ahead.
Semi eigen.
Semi.
Because the eigenvalues
Yeah, no. What will be the inverse of this matrix? Inverse. Like, I mean, uh, doing the adjoint and all. Or we can do it just, yeah, I'll just do it. Right. So, what should I do now? I'll have to do 1 minus 1 by alpha times of alpha. This will be alpha. This will be 1 minus 1 by alpha. 1 minus 1. Wait a minute. So determinant 1 होगा. Adjoint of this will be 1 minus 1. This will be 1. Adjoint of this will be minus alpha. Adjoint of this will be 0. इसका होगा alpha. अल्फा आ रहा है ना? हाँ अल्फा. इसका आएगा 1. इसका आएगा 0. Now what? Now इसका आएगा अल्फा स्क्वायर. Yep. And इसका आएगा अल्फा. Just check whether this is the inverse. 1. Okay, this would be minus. This should be plus. This should be minus. Right. Just check whether this is the inverse. One, है ना? This would be alpha plus alpha minus. एक minute. Alpha. 1 minute, guys. 1 minute. Oh, ये minus alpha कैसे होगा? This would be 0. So this would be 0, no, alpha. Correct. What the, this would be 1 fine. ये क्या होगा? ये will be alpha minus 0. Wait, I'll just write out the pen and paper. 1 minute, guys. 1 alpha 0, 0 1 alpha 0 0 1. इसका joint होगा 0 0 alpha square 1 0. This will alpha d होगा 1. अल्फा स्क्वायर आ रहा है।
भाई आगे बढ़े कैसे?
नहीं आगे नहीं, ये इन्वर्स निकालने में इतना, एक मिनट भाई, एक मिनट। इन्वर्स, मैं बस इसका इन्वर्स निकालना चाहता हूँ और कुछ नहीं। आई मीन इसका, ये तो इन्वर्टिबल है ना, तो इसका इन्वर्स तो होगा ही।
ओके
हाँ गलती हो गई। 1 सही, अल्फा सही, अल्फा का ये क्या होगा? 1 minus 0, नहीं 0 minus 0।
I think that is adjoint, that cofactor we are finding, na?
Yeah.
That is like we have to take uh, uh, what we call transpose of that, right?
Okay, yeah, right. Okay, yeah, now it makes sense. Yeah, okay, fine. Then we would have 0 1 minus alpha, and then you would have 0 0 1, right? Then yeah, 1, yeah, 0 alpha square minus alpha square, yeah, 0. Perfect. Thanks a lot, इसका ट्रांसपोज होगा 1, आ गया 0 0 0, ये क्या, ये 1 था, माइनस अल्फा अल्फा स्क्वायर माइनस अल्फा अल्फा स्क्वायर माइनस अल्फा, this is 1. So this is the inverse. Okay, so now what I'll do, no, I'll just multiply this matrix by 1 alpha 0 0 1 alpha 0 0 1, and I'll matrix this by 1 minus alpha alpha square 0 1 minus alpha 0 0 1. What I'm doing, call this matrix A, right? Call this matrix P. Then what is this matrix? P inverse, right? So what I'm doing, I'm constructing B equals to PA P inverse, right? What is the benefit? The benefit would be that when we do B power 8 now, when we do B power 8, this will be equal to P into A power 8 into P inverse, right? But we know A power 8 is already 1, so this would be I, right? That is the benefit. Now observe that as you vary alpha can be any real number, right? So as you vary alpha, you will get uncountably many matrices. Is this okay?
Hmm.
Okay, so basically we are doing that. This given matrix is a diagonalizable, right? And the diagonal this that matrix one alpha zero zero one
No,
alpha
means
zero
that
zero.
time G will
I mean,
be.
diagonalizable, that doesn't like come into picture. I mean, where do we require it?
So that basically you have used P A P inverse.
Yeah, that's all, that's all.
Okay,
So that PAP inverse into
that
PAP inverse,
yes yes
right? So
that
if you
that
go on doing
matrix
this,
yeah that matrix
yep.
A is similar to the identity matrix.
Oh, if A
You're
is
saying
Similar to that, so yes.
if A is similar to identity,
Yeah,
then
A to the power.
the eigenvalues of A and the eigenvalues of I will be same, right?
Yes, 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 yes.
But eigenvalues of A is minus 1 is an eigenvalue of A, but minus 1 is not an eigenvalue of I. That means A is not similar to I. Is this okay? Hello?
Yes, yes.
Yep, thanks. Okay, that's it. Fine. But intuitively, if you want to solve, I mean, in the exam hall and all, no, just you can think about this idea. Like, take a plane and reflect about that plane. So that plane can be chosen in uncountably many ways. Right? So there are uncountably many such maps. Okay. Yep, that's pretty much it. Let's go to the next question. Okay. 1 minute, guys. Let me just put this on charge. 1 minute.
Position भाई
Yeah.
इसका आंसर ए एंड डी आ रहा है ना 12 का
इसका आंसर ऑनली डी आएगा ना.
ये भी तो आएगा ना इनवर्टिबल आ रहा है ना
किसका आंसर बोल रहे हो? विच आंसर?
12 का
12
Let's do 12. 12 is easy, no?
आंसर इज ए एंड डी राइट
Answer, I don't know what is the
I
answer.
don't know. I mean, I didn't do this. Okay, let's see. Okay, so what are they asking for? So what does this mean? This means x square minus 7x plus 12 is an annihilating polynomial. Okay. Okay, fine. Then what else do we have? So let's look at the roots of the annihilating polynomial. Okay, so this would be x minus 4 into x minus 3, right? Yeah. So yeah.
4
So
3.
what can we say? A is invertible, yes, because why is A invertible? Because the polynomial x does not divide x minus 4 into x minus 3. This is why A is invertible. Okay. Now this is option A. What about B? B says t square minus 7t plus C.
Okay,
Okay,
what is the
so
meaning of what is the meaning of x here?
yeah, I mean as polynomials, polynomial division.
Okay. No. Why are you dividing by x? These are my questions.
Okay, yeah. So what I mean to if I write instead of x, if I write x minus 0, now is it clear?
Okay, then
That means x minus 0
zero is
is
an
not a
eigenvalue.
factor of the characteristic polynomial. That means 0 is not an eigenvalue. What does that mean? That
Okay.
means determinant of A is not 0. Right? This is
Okay.
okay.
So basically you are telling that if a learning polynomial is 2, so surely its characteristic polynomial will be less than 2, either 2 or 1.
Yep.
Right.
Characteristic polynomial.
So
Yeah, I mean, what I'm saying is the minimal polynomial will
I
be,
am
so instead of this, I should have written minimal polynomial. Yep.
No, no, no. See, minimal polynomial is dividing the characteristic polynomial, and characteristic polynomial is dividing the annihilating polynomial. Am I right?
Correct. Correct.
Here, what I'm confirming with you, if lambda square minus 7 lambda plus 2 is 12 equal to 0. If this is
Yep.
annihilating polynomials of degree
Yep.
2, so the characteristic
Mm-hmm.
polynomial will be the at most degree 2. Correct? And since it will be divisible, so either the roots will be 4 or 3. Am I right? Eigenvalue.
See, okay, I want to make one more, what do you say, like, one more distinction here. A small point to be noted, okay, that the characteristic polynomial, right? Mm, in fact, I think I should change this notion of characteristic polynomial dividing the annihilating polynomial, and I should keep it simply as minimal divides the annihilating polynomial, because this is always of degree n. Characteristic polynomial by definition is of degree n, right?
Mm,
है ना भैया?
mm,
मतलब by definition ये
mm.
degree n. तो this is a safer way. मान लीजिए ma divides the annihilating polynomial. That means x minus 0 is not a factor of ma. That means 0 is not an eigenvalue. That means determinant of a is not 0. Okay.
Okay. So one more thing I want to tell, that if in these questions, correct, if they are giving one more option, and option number E as the order of the matrix A must be 2. Can we conclude?
Must be 2.
Yeah. 2 cross 2 means 2 cross 2.
Okay. Okay. So basically you're saying n equals to 2.
Yeah.
This I am not very confident. I don't think so. Let me think about an example. Okay, 1 minute. Let me think about an example. Let's say, okay, let's take this matrix. Let's take this matrix. नहीं उसमें नहीं होगा. Okay, fine. हाँ ये matrix तो ले सकते. We can take this matrix.
Hello.
Say 4. Let this matrix be A, right? Then observe that A square minus 7A plus 12Y will be equal to 0, right? But the order of A is 3, right? This is okay. This is 3 by 3, right? So order need not be equal to. Actually, that is why I removed this characteristic wala argument.
Okay. But you are telling that the characteristic will always divide the annihilating. Am I right? So
Now I changed it.
Minimal polynomial divides.
Minimal will divide the annihilation, and minimal will divide the characteristic.
Yes.
These are actually two different. Yeah.
Okay.
Thanks for that.
That was confusing me. Okay.
Yep. My bad. Yep.
Okay. Sure.
वैसा कोई रिजल्ट ही नहीं है ना शायद कैरेक्टरिस्टिक पॉलिनोमियल
शायद
डिवाइड
नहीं. Yeah, it's actually I think it's not there.
बिकॉज रिजल्ट ऐसा है कि मिनिमल पॉलिनोमियल डिवाइड्स एनालिटिक पॉलिनोमियल एंड कैरेक्टरिस्टिक इज वन ऑफ द एनालिटिक पॉलिनोमियल.
Right. That's all.
What, Tyler?
Characteristic polynomial is the particular example of analytic polynomial.
Yep. Correct. Okay, so that's pretty much it. Let's see. What are the other options? D square minus 7D plus 12 equal to 0, where D is determinant of A. This need not be true, right? Because
They has to be root. Yes.
what if you take this matrix, right? What will be the determinant? 12, right? So 12 square minus 7 into 12 plus 12 will not be 0. 12 square plus 7 into 12, sorry, plus and minus, sorry, minus 7 into 12 plus 12, right? This will be 12 square minus 12 into 1 minus 7, that is minus. So this is never 0, right? This is not 0. So this is false. What about option B? Option B says oh, you look at the trace, okay.
No, no, no.
So let's take this matrix only. What will be the trace? The trace will be 7. So 7 square minus 7 into 7 plus 12 into n, which is 12 into 2, right? This is definitely non-zero, right? So this is also false. Right? But D is correct, right? Because why? Because this is an annihilating polynomial, right? Because of annihilating polynomial, and since minimal polynomial will divide the annihilating polynomial, right? Because of this, D is okay. This fine. This is fine. I hope this is fine.
Thirteen.
Yeah, 13 will skip, okay, because I do
Now,
I
now
have
teach me how to find.
huh? Hello?
Okay, okay. You have okay. You want to revise the concept first.
Yeah, right,
Yeah,
right.
yeah, got it.
Because
Yeah.
Jordan canonical, I'm not very confident about. I don't even remember the definition.
Yeah,
So
उसका आंसर सेम
Okay.
है.
okay,
आंसर सेम.
वो
okay.
देखना पड़ेगा.
Actually, I forgot the definition of Jordan canonical form.
Yeah, it's totally depends on the minimal
I also
polynomial.
not very.
Yeah. Okay, so let's move ahead. Let's look at 14. Okay, VB vector space of polynomials at most 3 dB differential. AB, okay. A is true, right? A will be an nilpotent matrix, right? Is this clear? Why?
Potent कैसा है? इसका दो रो मीन्स टू कॉलम विल बी जीरो.
Uh, yeah.
दो कॉलम जीरो आएगा. But how it will be then?
It will be nilpotent because you take any polynomial, keep on differentiating it. At some point, it will be 0, right?
Okay.
That means
Yes.
that it is nilpotent, right?
Yes.
That's fine. So if it is nilpotent, then it cannot be diagonalizable.
Okay. Yes. Exactly.
That I have discussed in the recorded video.
Yes.
Yeah, and the rank is
क्या
2.
बोल रहे हो?
Okay, I'll write it down just for the sake of completeness. I'm not including the last option. Okay. Yeah, so why is A nilpotent? Because so you do d power okay, d of a0 plus a1x plus a2x square, that is equal to so let's do d3, right? Oh sorry, one more we should a2x square plus a3x cube. Let's do d4 of this, right? What would that be? That would be first differentiation, that would be a1 plus 2a2x plus 3a3x square. Again differentiate, we'll differentiate 4 times now. So this will be 2a2 plus 6a3x. This is first differentiation. This is second differentiation. What will be the third differentiation? 6a3. Third differentiation. What will be the fourth differentiation? 0. What does that mean? That means d4 is 0 matrix. Is this okay? or you can say a power 4 is 0. That means A is nilpotent. So one more thing, that nilpotent, if a matrix is nilpotent, that implies that it is diagonalizable. This is
Except zero, right?
uh,
Means non-zero nilpotent matrix.
what is it?
Non-zero nilpotent matrix, right?
Yeah, yeah. Right, right.
Yes.
Correct, correct. Non-zero. So this is in the recorded video. Okay. The rank of A is 2. Yeah, rank of A is not 2. Rank of A is 3, right? Rank is 3. Rank is 3, no?
No, 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 no. Nullity will be two.
Nullity will be
Two.
nullity will be 1, right?
No, 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 no. It is on the complex means polynomial.
Ah, okay,
So
okay,
one
okay.
over
So
I ये दो भी आएगा ना basis.
right, 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 right,
So
right.
के दो column will
1
be
minute, 1 minute, 1 minute, 1 minute. Uh, no, no, no. This is okay. Actually, yeah, I'll tell you. So, so what is rank? What is rank of A? Rank
the
of A is
matrix
the
will be the 4 cross
dim
4, right?
dimension of image
Dimension
of,
of the matrix will be the 4 cross 4,
yeah,
right?
dimension with respect to C. Okay.
Yes.
Now is it clear why it will be 3?
No.
Okay. It will be 3 because look at the image. What is the image? A1 plus 2a2x plus 3a3x x square, right? So a1 can be chosen, a2 can be chosen, a3 can be chosen. So there are 3 degrees of freedom. This is okay. Or you can say that what will be the nullity? Nullity will be all constant polynomials k. All constant polynomials will be nullity. But this is of dimension 1. What does that mean? That means rank would be 4 minus 1 versus 3. This is also another method. This is okay? Fine. Is this okay? I hope this is
Okay.
okay.
Yes. What is the dimension of this polynomial? Over C. It will be
Dimension of
the
polynomial or
yes.
vector
Means
space
dimension of V over C.
over C would be 4.
But
Dimension
we
of
have a
V,
complex, right?
this will be 8. Is it
Okay,
okay?
okay, okay, okay. Yes, yes, yes.
Yep. Over C it will be the same only. Nothing to worry. When you
Yes.
take dimension over R, then you have to choose. Okay, shall we move to the next question?
Yeah.
15. Wait 1 minute. I'll just stop recording. Okay, 1 minute. Shit.